All right, you are welcome again. We are talking about Laplace transform. And under Laplace transform, we are considering the basic properties of Laplace transform. All right. And then in our previous video, we have taken some of the properties. We have taken property number 1, linearity property. Property number 2, first translation or first shifting property. And then in this video, we are going to take property number 3, which is second translation or second shifting property. Right? Good. Please pay attention. Let's see what this property is talking about. So, what does this property state? It states that if the Laplace transform of a function f of t is equal to f of s, and g of t. Now, this is g of t, not the Laplace transform of g of t, but g of t is in two ways. The g of t could be f of t minus a if or when t is greater than a. And this g of t could be 0 if or when t is less than a. Okay? So now, these are the two conditions. Then, the Laplace transform of g of t is equal to e raised to the power of minus as f of s. Hello. This property is very interesting. All right, good. Let's carefully take a look at the theorem once again. We said that if we have a function f of t, and then when you take the Laplace transform of this function f of t, and the outcome or what you have is f of s, right? Good. And then you have another function g of t, and then this g of t is in two ways. It could be f of t minus a. It could be 0 depending on the value of t. So if t is greater than a, then g of t will give us what? F of t minus a. But if t is less than a, then g of t is going to give us 0. Okay, now the Laplace transform of this g of t combined with these conditions is giving us e raised to the power of minus as f of s. Hello. Now let's go. Let's take a look at this and let's solve. Let's see how we can prove this property. Please, I want you to pay attention. I'm going to explain it in details. All right, let's go. Going with definition of Laplace transform. You know, we have just talked about the Laplace transform, right? Good. Now let's take a look at, by definition, what do we mean by the Laplace transform of the function g of t? The Laplace transform of g of t is the integral from 0 to infinity. Okay? E raised to the power of minus st, then the function g of t dt. Hello. Good. Now look at this. The integral from 0 to where? To infinity. Now look at this number line. We have the number line. T is from 0 to where? To infinity. T is from 0 to where? To infinity. But they are trying to tell us that t can have a value. Okay? There is another point in between the 0 to infinity. Let's call it point A. Then we'll say that if t is greater than a, that means what you are going to have is what? Is f of t minus a. But if it is less than a, if t is less than a, it's going to give you what? 0. Now look at this. In this number line, from 0 to infinity, we have another number a. Okay, so for us to integrate now from this 0 to infinity, we will divide it into 2. Hello, we have just divided into where? Into 2. Now, the integral from 0 to a, and then another integral from a to infinity. Then we join them together. It's still going to give us the same thing, the integral from 0 to infinity. Hello? Good. Now let's go. Now, with this number line, we have from 0 to infinity, and we bisect now at a point A. And then we are going to do it from 0 to A plus from A to where? To infinity. Let's go. Let's see what we are going to have. That means we are going to say that it's going to give us the integral from 0 to A. E raised to the power of minus st, our function g of t dt, plus the second one now, from A to infinity, e raised to the power of minus st g of t dt. Hello? I think you are getting what we are saying, what we are doing here, right? Good. Now let's go. Again, look at this. G of t has a specific value depending on the value of t. Yes, g of t has a what? A specific value depending on the value of what? Of t. Good. When t is greater than 0, it gives us something. And when it is less than 0, it gives us another thing. Okay? Now, in the first side now, okay, where we say 0 to a, 0 to where? To a. That is to say that t is less than a. Hello? T is what? Is less than a. So when it is less than a, what are we going to have? That means that g of t is 0. G of t is what? Is 0. Good and fine. Let's say we're going to have the integral from 0 to a, e raised to the power of minus st. In place of g of t now, since our value g of t is 0 when t is less than a. Alright? Good. That means in place of g of t, we write what? 0 dt. Then we say plus the integral from a to infinity. From a to infinity is telling us that t is greater than a. Look at the number line. T is what? Is greater than a. And when t is greater than a, by our definition or from our definition, we say that when t is greater than a, that g of t gives us what? F of t minus a. Is that true? So now in place of g of t, we write what? F of t minus a. Then we have dt. Alright, good. Now look at this first one where we have the integral from 0 to a, e raised to the power of minus st 0 dt. So when this 0 multiply all this, everything turns to what? 0, remaining one part. Okay, so the one part that is remaining now, we have the integral from a to infinity, e raised to the power of minus st f of t minus a dt. Hello? Good. Now let's go. From this function now, we can say let t minus a be called the letter u. Hello? Let what? T minus a be called the letter u. Okay? Good. Now, if it is called a letter u, when you differentiate this function t with respect to u or u with respect to t, you are going to say that the t is equal to the u. Hello? You are going to see that what? The t is equal to the u. Alright, now let's go. Again, we have t minus a is equal to u. Can we make t the subject? Yes. We take a to the other side. Taking a to the other side is going to give us u plus a. Alright? So that is to say, anywhere we see t minus a, we are going to write what? U. And then, anywhere we see t, we are going to write what? U plus a. And anywhere we see the t, we are going to write what? Du. Because the variable have changed from t to what? To u. And then when we differentiate either t with respect to u or u with respect to t, make the t the subject, we have the u. So in this case now, anyway we see the t, we replace it with the u. Is that clear? Good. Now let's go. In a value here, where we have the integral from a to infinity, we have e raised to the power of minus st f of t minus a in bracket dt. Let's go. Let's substitute properly. In place of t, we write open bracket u plus a. Is that true? Yes. And then again, in place of t minus a, we write u. Okay, good. And then dt now being replaced with what? Du. You can see the equation. It have changed. Very well, and it's very beautiful. All right, good. Now let's go. In the power, let's open the power clearly. When you open the power, use minus s to open the bracket. In the exponential or in the powers, what we are going to have is this. We have the integral from a to infinity e raised to the power of minus su minus as. That is when you use minus s to open the bracket. Is that clear? Good. We still have f of u du. All right, good. Now, in the law of indices, we can combine and we can still separate, right? Good. Then we say that this e raised to the power of minus su minus as is the same thing as saying e raised to the power of minus su times e raised to the power of minus as. When you want to combine these together, they have the same base. You just add their power. Okay, so adding their power is still going to give you back minus su minus as. Is that true? Yes. So we have not done anything magical here, right? Good. Here we have f of u du. Good. Let's go. In integration, when you have a constant, what do you do with a constant? You take it behind the integral sign. And then in this case now, our variable is u. So any value that did not have this u, we take it as a constant. Any value that did not have u, we take it as a what? As a constant. Now take a look at this. We have the integral from a to infinity e raised to the power of minus su. We have u there. So this is not a constant, right? Good. The next one we say times e raised to the power of minus as. Minus as. We have e raised to the power of minus as. So the whole of this e raised to the power of minus as is what? Is a constant. So we take it behind the integral sign. So when we take it behind the integral sign, what do we have remaining? So here we have e raised to the power of minus as, the integral from a to infinity, e raised to the power of minus su, f of u du. Hello. I hope you are following, right? Good. Thank you. Now let's go again. Recall that when you say the integral from 0 to infinity, e raised to the power of minus st f of t dt is equal to f of s. Is equal to what? F of s. So in this case now, what do we have? We have the integral from a to infinity, e raised to the power of minus su, f of u du. In this, by definition, the variable is t, but what we obtain now, the variable is what? Is u. And then, from the definition, the parameter is what? Is s. Alright? And then what we just solved, our parameter still remain what? S. But our variable is u. Okay? So now, that is to say that what we just solved is the same as saying e raised to the power of minus as, the integral from a to infinity, e raised to the power of minus su f of u du is e raised to the power of minus as f of s. Hello. This the integral from a to infinity, e raised to the power of minus su f of u du is the same thing as saying f of s. Then we have a constant behind, which is e raised to the power of minus as. Hello. Yes. So this is what we call the second translation or the second shifting property. All right, please, I want you to watch this all over again until you get the basic concept. It's very simple. All right, now we have discussed the first property, second property, third property, and we are still going on to discuss many properties. All right, yes, thank you very much for watching. Please, if you are new to our YouTube channel, please do us a favor and click the subscribe button. Give this video a thumb up if you like it, and then also make sure you share our videos. Stay blessed. Thank you.